Hi everyone, welcome in new energy efficiency tip of the day. Our subject will be related to efficient steam system control. We will try to cover all the related areas that contribute to the problem. We will start with the flow control. The problems of the flow control that we can see that in some of the cases there is no steam flow meters installed either on the production or on the consumer side. Most of the system providers can give us only the system with the main consumer flow meters installed, but the others are not provided as a part of the package. Also, we have seen some practices like that those flow meters, no one is calibrating them regularly. So the impact of those two practices that we will have missing of important data that we need for plant efficiency, energy efficiency, process control, costing and other issues. So we cannot build on those kind of non-reliable data, you can say. The proposed solution that we use steam flow meters when it is feasible, and it is highly recommended to consider that installing those if your major consumer of steam has no flow meters. This is due to one simple fact that we can only control what we can measure. So without a proper measure, we cannot see what is happening in the system, and we cannot make any proper tuning for the system. The second area will be related to pressure control. Most of the common cases what we have seen that at generation side, especially the boiler side, the problem that people have the tendency to reduce the steam pressure. They are lowering the pressure of steam at the boiler, and they are running the boiler at pressure lower than the design. They thought that by this action they will provide steam more efficiently to the consumer that are using this steam at lower pressure than design. The impact of that will be the boiler will be running at poor efficiency. The steam consumption, because of the heat content for the low pressure steam, will be lower than the high pressure steam, so the high steam consumption will be seen. Also, we will have some impact on the high fuel consumption from the boiler side. At the consumer side, we will have those kind of problem that we will have unstable or pressure poor control if we have installed a system which is not performing well. The impact will be on the performance fluctuation. So we propose that at the boiler side, as we said, we should generate the steam at the maximum pressure accepted, just to ensure that the boiler is running at the maximum efficiency possible. At the consumer side, we should also use a suitable let-down valve. Either it should be a direct acting control, pilot operated, pneumatic operated control. Also, we can think about installing advanced process control loops for controlling the pressure. This also will have a good impact on the overall performance and decrease the losses. Regarding the temperature control, the problem that maybe we have installed a poor inlet steam control for the system, and if this happen, the impact will be performance fluctuation, overheating, discomfort for the application like the HVAC and other things, mechanical damage if the temperature exceeded the maximum allowable, loss of efficiency also can be seen. We recommend use a suitable temperature control. As we said, also we can think about the advanced process control, self-acting regulation valve. Try to avoid the manual control valve or the manual control as much as you can, and think about the advanced process control. This also will be one of the good retrofit that you can make for your own system. For the condensate removal, in the picture we can see some of the different types of the traps that we use, and in the next video after this one we will discuss in detail the performance and testing of those kind of types of steam traps. But generally here we can say that the problem, if we have a poor steam trap performance, this will have an impact on the performance fluctuation, water logging, because the trap will not be properly removing the water from the system, loss of efficiency, definitely water hammer because of the accumulation, and the water hammer will cause vibration, and this could make a damage for the lines supports. The solution, we should consider the aspects when we are selecting our steam traps, about the differential pressure, about the size of the discharge orifice, the condensate temperature, the condensate flow that will come with the system. We should think about this when we are designing or selecting the proper condensate trap. The common result of all those areas that we will have this high operational and maintenance cost, and this will be significant. Maybe you will not feel that on the short run, but on the long term you will feel that there is a lot of losses, and there is a good opportunity if we found one of those area or one of those problems as we discussed before, and try to solve them as we proposed. This will be a good saving in our steam system. So in order to see what other things also we can do in terms of action, we should check our existing steam flow meters regularly, and we should make also a list of those flow meters. We should calibrate them according to at least every 6 months should be one calibration for that. And most of the energy standards like the ISO 15001 also recommend as a mandatory requirement to have those kind of calibration for the list of the flow meters, especially for the significant energy users in the system. Also, we should consider increasing the boiler pressure close to the boiler design pressure, and adjust the steam pressure at the consumer side with the let down valve. We should also apply regular function steam traps maintenance. As we said, we should be like testing maintenance program for those kind of trap. Also, we can calculate the feasibility of using let down extraction turbine instead of the let down valve, to use this kind of or to recover the energy rather than wasting this to break it down on the valve. Most of the ammonia, methanol, syngas plants already using those kind of extraction turbines as a part of the steam system as a main let down devices. Also, we should check the existing steam inlet temperature. See the trends that we have. If the control system is not performing, we should think about installing advanced process control. We could do also the same about the pressure. If the trend is showing high fluctuation, also this means that our system need proper tuning, and this tuning will have a great impact on the performance. This was a quick tip related to this steam system control. I hope you find it useful for you. For more tips, please visit our website 360proactiveengineer.com, and I will leave a link to download this kind of map with the presentation for your future reference. Thank you so much. See you on the next step. See you.